Ever think about it? Like how people way back when, no satellites, no nothing, figured out the universe. It's wild, right? Their minds, maybe some basic tools, that's all they had. Totally different from us. But maybe their way of looking at things, those basic ideas, could they still have something to teach us today? Something deep.
It's a thought, isn't it, that something from centuries ago could still matter, could even change how we see science now.
Exactly. And that's the journey we're on today. We're calling it Ancient Code, Modern Mind, right? And we're going deep into the code, the real code, inside these super important ancient texts. Not just translations, but the logic, the math behind it all, astronomy, how they understood the whole cosmos. And get this, we've got a secret weapon, AI, artificial intelligence, right? Think of it like our super tool. Cuts through all the hard stuff, finds hidden links, maybe even helps us understand these ancient languages better, all so we can get these awesome ideas clear for you.
So we're mixing history with modern analysis, trying to connect that ancient wisdom to how we see the world now.
You got it. And to kick things off, we're going way back, 5th century CE, to a guy named Aryabhata. This guy was a total genius, mathematician, astronomer, right in the middle of India's Gupta Golden Age. Now, you might know him from Pi, the formula, but his work, his big book, the Aryabhatiya, it's so much more than that. We're talking about models of the planets moving, accurate too. He understood the Earth, that it's a sphere spinning in space. And then there's this algorithm he came up with for solving equations that's still used today in cryptography and all.
The cool part isn't just what he did, it's how he figured it out. What were the big mysteries he was trying to solve? How did he build this whole picture of the universe using what he had back then?
That's what we're after. Aryabhata's mind, the puzzles he was working on, his whole framework for the universe. His book, the Aryabhatiya, it's surprisingly short. 121 verses split into 4 parts. They're called padas. You've got the Daśagītikā, the cosmic principles, the Pada, all about math, the Pada about time, and the Golapada about the celestial sphere. For this deep dive, we're going into the Daśagītikā, the first part, the foundation.
And as we go through it, later commentaries are going to be so helpful, especially Bhaskara Afir from the 7th century. His interpretations are like keys to unlock the meaning in Aryabhata's verses, which can be pretty dense and poetic sometimes.
Totally. Bhaskara is like our bridge across time, helping us understand the context, the little details in Aryabhata's work. Now, to really get Aryabhata, we got to zoom out, see the world he lived in. 5th century India, Gupta Empire, they call it a golden age, and there's a reason. It was booming, intellectually, artistically. Imagine debates in temples, the Ajanta caves, these incredible paintings, Kalidas's poetry. Wow. See, it wasn't just pretty art. That stability, everything connected, that's what let someone like Aryabhata come up with these revolutionary ideas about math and the stars.
Sounds like they valued thinking, big time. Art, science, philosophy, all linked together in this thriving culture. What was behind all this?
Okay, so the Gupta Empire, they've been in charge for a while, brought stability. That led to a good economy, trade routes east and west booming. That meant resources, space for ideas to grow.
So not just stable politics, but a lively economy and culture. That's what allows for new ideas.
Exactly. And the center of it all was Pataliputra. Aryabhata called it Kusumapura, city of flowers. Imagine this bustling city on the Ganges, not just for trade, but for ideas. Scholars everywhere, Hindu, Buddhist, Jain, they'd meet, argue, share knowledge. Like Nalanda, that famous university attracting people from all over Asia.
A diverse place, lots of intellectual energy, different schools of thought, interacting, coming up with new stuff. Amazing.
Right. And that's where Aryabhata was born, 476 CE, Pataliputra. Here's the crazy part. He wrote his big work, the Aryabhatiya, around 499 CE. He was 23 years old. It tells you something about the times and about his talent. He probably studied Jyota, which was astronomy and math together, really deep stuff. Maybe he even used tools like the gnomon or khyughṛ to track the stars.
Yeah, it's interesting. Some scholars had kings sponsoring them, but Aryabhata's work doesn't seem like that. Maybe he was driven by his own curiosity, a different way of supporting knowledge.
Good point. It's like he really wanted to understand, the universe, how it works using reason and math. His Aryabhatiya, it's short, 121 verses, but so powerful. The genius is how he combines math and this vision of the universe. It wasn't just theory. It had practical tools, influenced Indian astronomy for centuries, even some early trigonometry in there.
So it's both philosophical about the universe and math, and super practical at the same time.
Exactly. That's why we still talk about him. He shows how powerful our minds are, not just seeing the stars, but really understanding them with math. Okay, so now we're going into the Aryabhatiya. First stop, the Daśagītikā. It means 10-verse song, but get this, it's actually 13 verses. These verses, they set up everything, his number system, the astronomical basics, the whole deal.
And it's a Gita poetry, right?
Right.
So it was meant to be memorized, passed down orally. That's how they preserved knowledge back then.
Super important. Imagine trying to remember all those calculations without writing them down, passing them on for generations. The poetry helped. So in the Daśagītikā, Aryabhata's goal was clear. Encode the patterns of the universe, short, memorable.
Where does he start?
Like a lot of ancient texts, he starts with an invocation. First verse of the Daśagītikā, Katikapata, verse 1. Right away, you feel the reverence, and he states what his work is all about. It starts. Prashpatyekam anika konsekya devatat parabrahma.
Whoa. Sets the mood right. What do those words mean, though?
Okay, so Prajapata means bowing down, showing respect. Then there's Ka, probably Brahma, or Prajapati, the creator god. Then Ekam, the one. It's the ultimate reality, Brahman. And then Anikam, the many, the universe we see, all the different forms that come from that one source. And finally, Sekya Devata Para Brahma. That's the true divinity, the absolute, the unity and diversity all together. So right off the bat, Aryabhata is linking his science to a bigger picture, a unifying principle behind the universe.
So math and astronomy aren't separate from this deeper understanding. It's like he's trying to find the order in what seems random, the math behind the universe.
Exactly. He sets the stage with these big ideas. Then, the second part of the verse, he gets specific. Aryabhatas trigonometry gashita kalakriya golam.
And there it is, the core of his system, the three pillars.
Yep. It says Aryabhata sets forth three things. Gachita, that's math. Arithmetic, algebra, geometry, and the big one, trigonometry. That's his tool for astronomy. Then there's kalakriya, reckoning of time, measuring it from tiny units to vast cycles, calculating planet positions. And finally, golam, the sphere, spherical astronomy, the celestial sphere, planets moving on it, eclipses, all that. He puts these three right at the start. What does that tell us about how he saw the universe?
He saw it as a whole. Math is the language, time and space are the big players. Integrated system right from the beginning.
Totally. And remember, in the 5th century, astronomy wasn't separate. It was tied to religion, the calendar, their whole worldview. With that invocation, Aryabhata is acknowledging that. But then, bam, he switches to math, geometry. This first verse is like the whole Aryabhatiya in a nutshell, sacred and scientific together. Math helps us understand the divine universe.
Powerful start. Sets the stage for everything that comes next. So where does he go from there?
Verse 2, he drops this mind-blowing thing, his own number system using the alphabet. Genius, so efficient, especially for passing knowledge down orally before widespread writing. Think of it like ancient data compression.
Alphabet of the infinite, they call it. How does it work?
It's pretty neat. He takes the Sanskrit consonants, splits them into two groups. First, the Varga letters, Gautama, they get values from 1 to 25. Then the Avarga letters like Yara, La, Ha, they're multiples of 10, 30, 40, 50, and Ha is 100.
Okay, consonants for the base values.
Yeah.
What about vowels?
Vowels are multipliers, 9 of them. A is 1, I is 100, U is 10,000. It goes up by 100 each time, is 1,000,000, and so on. O, that's a huge number, 10 to the power of 16. Combine a consonant and a vowel, and you get a big number in just 2 sounds.
Super efficient. Give us an example.
Sure. Ku. Consonant ka is 2. Vowel U is 10,000. So ku is 2 times 10,000. That's 20,000. Or ya. Consonant ya is 30. Vowel I is 1. So ya is just 30. It's elegant, compact.
Not just for abstract math, though, right?
Yeah.
This system was used for real astronomical data, like planetary revolutions over huge timescales.
Well, right on. Like in verse 3, he uses it to encode how many times things go around in a Mahayuga. That's a massive time cycle. Remember the sun's revolutions? Khyughṛ. We said ku is 20,000. U, that's ya, 30, and U, 10,000. So 300,000 to go. That's ga. 4 million, 4 million. Add them up. 4,320,000 revolutions.
That many times the sun goes around the earth in one Mahayuga, according to him. Crazy how such a big number fits into 3 syllables.
Right. And Bhaskara, I even said this encoding helped them keep that precision, passing it down orally. But there's a twist. In verse 2, Aryabhata hints at another way to read these encodings. Varga letters should be in Varga places, Avarga in Avarga places, kind of like a chessboard, certain pieces on certain squares.
There's another layer, right? Maybe it let him encode even more complex numbers.
Could be. Maybe for numbers that didn't fit the simple adding method, like the moon's revolutions, that's a really big number. Sun's revolutions, easy. But this other method, more structured, maybe for those complex ones, it shows how important this system was. Oral tradition, remembering knowledge. He made these massive numbers into something you could say, remember, pass on.
Brings us back to that reverence for the cosmic order, verse 1. He's not just observing. He's capturing these grand cycles, making them into language and math, something people could remember for generations.
So he's got his awesome number system. Now he tells us how many times things actually revolve in a Mahayuga.
Verse 3, right, that's where the specifics are. Mahayuga, we say it's 4,320,000 years. That's Aryabhata's main timescale. Now remember, this is a geocentric view, so those revolutions, they're around the Earth.
Right, he's figuring out the average speed, super important for calendars, predictions, all that. The word he uses is haganlo, revolutions in a Mahayuga. Then he lists them, all encoded.
Like what?
Sun, Ravi, we did that one, 4,320,000, khyughṛ. Then the moon, way bigger number, 57,753,336. Those are sidereal orbits. It's encoded as Taijut. And here's where it gets really interesting. Earth, ku, that number is massive, 1,582,237,500. Yushibuthyo. And he says those are eastward rotations, Brock. This is radical. He's saying the stars seem to move west because the Earth is spinning?
Wow. Back then, they thought the Earth was still the center.
Exactly. He gives revolutions for the planets too. Saturn, Shani, 146,568. Jupiter, Guru, 364,224. Sidereal, that means relative to the stars, the fixed background. The true orbit, like if you were watching from deep space, using those numbers in the Mahayuga, we can actually calculate the orbital periods he's implying. The moon, about 27.4 days. The real value is 27.32, super close. Saturn, about 29.47 years. Real one is 29.46. Jupiter, 11.86 years. The sun, from Earth's rotation, is 366.26 days. Real value, 366.25. Amazing accuracy, especially for his time.
Mind-blowing. The precision they could get back then really shows how carefully he observed how good his calculations were.
It does, and this was important stuff for them. Knowing the stars, it helped with farming, rituals, astrology was a big deal back then.
Verse 3 gives us the average speeds, but to say where something is at a specific time, you need more than averages, right?
You got it. Verse 4, it's like switching gears. From those long-term averages to specific points in the sky. Imagine knowing the average traffic on a highway, but now you want to know where each car is right now. This is where he brings in apogees, uko, that's the farthest point from Earth in an orbit, and nodes, pata. That's where the moon's orbit crosses the sun's path, the ecliptic. These points, they help you calculate positions way more accurately.
Because they affect the speed, the apparent path of those objects.
Exactly. For example, the moon's apogee, he says it goes around about 488,219 times in a Mahayuga. That point matters because the moon's speed changes in its orbit. Slower at the apogee, farthest away. Then the moon's ascending node, 232,226 revolutions, and here's the key. It moves viloma, backwards. That's precession, the moon's orbit wobbling. Super important for predicting eclipses.
Right. Eclipses only happen when the sun, Earth, and moon line up near those nodes.
Exactly. He also gives the revolutions for Mercury and Venus. But the outer planets, Mars, Jupiter, Saturn, he treats their apogees as fixed, maybe to simplify things. Then, a really crucial part, his epoch, day 0 for his calculations. He says, Budavni ajarka yogat pravetekra, means something like, the cosmic cycle began at Lanka dawn when Aries and the sun were together on a Wednesday.
Lanka, that was his prime meridian, 0 longitude, probably near Ujjain in India.
Yeah.
And Aries and the sun together, that's the vernal equinox, spring starts.
Right. This is his starting point for everything. Now, here's a little mystery. If you calculate it, that date, traditionally around 3102 BCE, it was a Friday, not a Wednesday. Scholars are still debating this. But regardless, this Lanka dawn, it's the anchor for his whole system. To actually calculate where things are, he used a tool called Trigonometry, the rule of 3.
Basic math idea, proportions, right? How to use it for astronomy.
Say you want to know where Jupiter is, 1,000 days after his epoch. We know its revolutions in a Mahayuga from verse 3, and we know how many days are in a Mahayuga. Rule of 3, you set up a proportion, figure out how much of a revolution Jupiter has done in those 1,000 days, multiply that by 360 degrees, you get its average position. Then, use the apogee data from verse 4, make some corrections, you get a more accurate position.
So verse 4 gives us the starting point, the tools to go from those big averages to specific predictions.
Yep, not just describing the universe, but predicting it.
Next, he puts his astronomy into this huge cosmological framework, right? Yugas, Manvantaras, Kalpas, all that. That's verse 5.
He's weaving it all together. Mahayuga, 4,320,000 years, 4 yugas inside it. Then the Manvantaras, he says it's 72 Mahayugas. And the Kalpa, that's 14 Manvantaras, 1,008 Mahayugas in total. Over 4 billion years.
Some other texts say it's 71 Mahayugas and a Manvantara. Aryabhata probably chose 72 to keep his system consistent.
Exactly. Now, the key part. He places his Lankadon in this timeline. How many kalpas, Manvantars, yugas had passed before the Kali Yuga started? According to him, 6 Manvantars. Then in the current one, the 7th, 27 Mahayugas had passed. And in the current Mahayuga, the first 3 yugas were done. So if you calculate it, about 1.986 billion years had passed since the beginning of the Kalpa, up to the Kali Yuga. That's deep time, right? Gives his astronomy this huge context. He also mentions the Thursday before the Barda War, linking it to that event. Again, there's that weekday thing. But the main point of verse 5 is this. He's setting the absolute 0 point in this cosmic cycle. It keeps everything consistent, connects his math to how they understood time back then.
Amazing how he combines precise calculation with his grand vision of the cosmos.
Totally. So we've got these vast stretches of time. Now he talks about space, measuring it. Starts with the whole universe, then zooms into Earth. That's verses 6 and 7.
Verse 6, it's about the celestial sphere, the khyughṛ. He uses yojanas, that's their unit of distance.
Yeah, the yojana, it's tricky to convert exactly, but think of it like several miles. Gives you a sense of scale. He gives a value for the circumference of this sphere. Commentators say it's huge, like 3.3 billion yojanas. Makes sense, right? Geocentric view, everything revolving around the Earth. And that same measurement, he uses it for the apogees and nodes, too. It's like he's setting the boundaries of his universe, how big it is.
Then, verse 7, we're back to Earth. Diameters of Earth, Sun, Moon. He says Earth's diameter is 150 yojanas, depending on how you convert that. It's really close to the real value. He gives diameters for the Sun and Moon, too. Moon's about 30% of Earth's. Pretty accurate. Important for eclipses, knowing those sizes and distances. He doesn't give measurements for all the planets here, but he does compare their sizes to Earth. This is a big deal. He's quantifying the universe, making the infinite measurable.
So we know the size of things. Now, what about their paths, their tilts, especially the sun, right? Verses 8 and 9.
Verse 8 describes the sun's path, the ecliptic. He says, from Aries to Virgo, the sun's north of the celestial equator. From Libra to Pisces, it's south. Equinoxes at Aries and Libra. That's what causes the seasons.
He's mapping out the sun's journey, how we see it from Earth.
Then, verse 9, it's about angles, the Bapakramā. That's how much the sun tilts, its maximum declination. He says 24 degrees, almost exactly right for his time. He gives the moon's maximum tilt, too, 4.5 degrees. And similar values for the other planets. These angles are important for everything. Seasons, how long the day is, eclipses, where planets move in the zodiac. It shows he understood the 3D geometry of the celestial sphere.
And finally, the math engine. This is how he makes those precise predictions. Verses 10, 11, 12.
The R sign table, early trigonometry, right?
Well,
and his system for keeping time.
Verse 10, it's got these 24 numbers encoded. They're the differences between R signs at intervals of 3 degrees and 45 minutes. You add those up, you get the R sign values for a quarter of a circle. His radius, R, is 3,338 minutes of arc, one of the first sign tables ever.
And verse 11 links that math to time. Movement in the sky connected to breath.
He says the stars move 1 minute of arc in 1 prec, about 4 seconds. That links angular movement to time, defines the sidereal day as 24 hours in his system. Then, verse 12, that's the rule for getting those R sign differences from verse 10, shows some serious math skills, maybe early calculus in there. These last 3 verses, they're like a toolkit. Trigonometry, timekeeping, essential for making those astronomical predictions.
So in the Daśagītikā, the first 13 verses, he sets up everything. His number system, his vision of time and space, the tilt of the ecliptic, the math tools. What an achievement.
It's amazing. Going through these verses, you realize how deep his thinking was. He wasn't just observing, he was building a model, the whole universe, consistent with math. It makes you think, right? This ancient code, math, astronomy, language, all mixed together. Could it give us new ways to think about knowledge, about the universe? Maybe understanding the past helps us appreciate science and technology today even more. What other codes are out there? An ancient knowledge waiting for us to unlock them with our modern tools?
It's a great question. Those ancient thinkers, they still have so much to teach us.
Next time, we'll go deeper into the Aryabhatiya. The Gupta, all the math, the Golopada, spherical astronomy. Maybe we'll even look at other brilliant minds from back then, see what secrets they hold.
Looking forward to it.
Thanks for joining us on this deep dive into ancient code, modern mind.